welcome back to Getting Started with Generative AI Research. So, as we discussed in previous videos, language models have some weaknesses. They sometimes fail in surprisingly easy tasks, and they also can exhibit undesirable behavior. But fortunately, we can mitigate some of these weaknesses through prompt engineering. So what is prompt engineering? Essentially, it's about creating optimal instructions or prompts for a given task that would improve the language model's performance. And since this whole ChatGPT revolution began, there's been a lot of talks about prompt engineering. Some claimed it would be the profession of the future. Marketplaces were created where people were selling their prompts. And I still sometimes see advertisement promising that there is a magical prompt that will suddenly magically solve, all my research problems. And I think we should be skeptical of such claims. And I want to illustrate this with one example. So let's look at what's called persona pattern. It's a very common approach where instead of directly asking LLM a question, you start by assigning a persona to the model. So for example, you might say you're an expert copywriter with more than 20 years of experience in writing high-performing copy, and only after that you would ask for actual writing help. There was an extreme example that I saw once on Twitter. So someone was claiming that thanks to ChatGPT, we could now get, Chris Voss to work for us for free. So if you don't know who is Chris Voss, and I didn't know, he is former FBI hostage negotiator, and he's well-known negotiation expert. And so this person on Twitter was claiming that he asked ChatGPT to behave like Chris Voss, and it helped him to negotiate their rent. But when I looked at the actual output of the model, because he also shared this actual output of the model, it was like a very general advice saying something like, you should tell to your landlord that it might be hard to find new tenants. They might spend some time on this and they wouldn't be getting rent in this period. And also new tenants might be worse than the current one. So, this is not like Chris Voss level negotiation. This is just, common sense. And I don't think we need any AI for that. Now let's look at some evidence, because there were a couple of papers that were investigating how well this role playing works. So for example, this paper compared two models. So this is not ChatGPT models, because sometimes it's prohibitively expensive to run experiments with ChatGPT or other private models. So this was done with two open models. And the authors of this paper, they were trying different roles and were checking how well models perform, and they ranked the performance from 1 to 160 and something, and you can see these ranks for two model. So I think there are a couple of interesting things in that plot. One of them is that results are kind of all over the place. So for example, for one model, roles of chatbot and roles of AI language model were performing the best, but for another model, you can see that the same roles was performing really poorly. It was one of the worst performance compared to one of the best. And the same was the role police. So for the role police, for one model, it was actually very good. But having 150 out of 160 rank for another model. What was also interesting is there was this role helpful assistant, which is usually a default role for language models. It was performing relatively well for both of the models, and also identified a couple of roles that were working very good for both models. It was mentor and partner, but we should be skeptical about that. So in a sense that we don't know if it can be generalized to other model. So I think the main conclusion is that there's no strong evidence that there is certain model that certain role that help your models to perform really well. And what's worse, there's not only no guarantee of increased performance, you can also get worse result, and sometimes they can become toxic. So in another paper, researchers were investigating toxicity in ChatGPT model when it's assigned a certain role. So they first assigned it a certain role of a person, and then asked it to say something about someone. And you can see in this case the result was kind of toxic result. So they started with this simple settings where they just checked roles of a good person, normal person, bad person, nasty person, and terrible person, and compared it with baseline when no persona was assigned. So the most interesting column is this POR. So this is probability of getting a toxic response. And for baseline, it was 13%, so 13% of responses were toxic. But if it was a bad person or a terrible person, the result was like much worse. It was like 96% and 94%. But surprisingly, even for a normal person, it was 38%. And even for a good person, it actually was worse than for no person at all. It was increased from 13 to 17%. And then they also compared some other personas, and they do it for dictators. And for dictators, the probability of toxic response was really high, but that's probably not surprising. What was again surprising is that if they tried to use head of democratic states, the toxicity was pretty high, 59%, instead of again baseline is just 13. And they did it also for business persons, sports person, journalists, and in all cases, assigning just specific role increased the probability of toxic output. So we should be really careful with this. It might sound like a good idea, but it could actually lead to much worse results. However, there were some roles that actually were working. So for example, in the next paper, what researchers was investigating if they can improve performance of LLMs in solving mathematical problems if they assign a role of math teacher, for example. So they started with this simple task, which is simple for humans, but not very simple for LLMs, because at the time LLMs was when computing, how tall is a person, they was doing something like 4 feet plus 3 inches equal 7 inches, which is of course not correct. And so the next attempt was to say, you are now an excellent mathematical teacher, and suddenly the model starts to work properly. So baseline performance in their test was 53.5%, so that's without any persona. When they assigned like a very simple persona, like just from now on you are a math teacher, please answer the following question, the performance increased a bit to 57%, and in their best attempt, when it was a bit more complicated prompt, they get 63.8%, so it's kind of 10% improvement, which is not so bad. What I think is interesting about this case is that we should be really careful about interpreting results. So because it doesn't work like that, like you ask a question, what is 5 plus 7? And then the ChatGPT tell you 11, and you say you are now a math teacher, and then suddenly ChatGPT started to work and provide you a correct answer. That's not what was happening in this paper. So if you carefully see of the actual output, you can see that instead of directly giving you an answer, it's now trying to do like some computations. So it seems what's happened is that assigning a role of math teacher helped model to start thinking step by step, and that was something that leads to performance improvement. And in fact, we actually know that this sort of thinking step by step, which is known as chain of thought, increased performance of models. So why this approach might work? It's probably because it allows for more compute time, or some would say that it allows a model to think longer. And the idea is that single word or token requires a fixed amount of computation, so producing more words requires more computation and somehow makes models smarter. So let's return to the example from my previous video where I asked the model how many letters are in the word raspberry, and it answered 2. When I asked it to actually count letters and I did it step by step, it suddenly was able to realize that the correct answer is 3, and it even apologized for the previous mistake. So this chain of thought idea was introduced in a paper where researchers were also testing how well LLMs could solve mathematical problems. And if they asked them to do it directly, just to give an answer, it often failed to do this because, as we discussed, LLMs were kind of struggling with reasoning tasks. But if they asked it to do it step by step to explain their reasoning, then the performance were better. So actually in their particular case, their performance jumped from 18% to 57%. So it's kind of remarkable jump for just one prompt. And it was even better than the state of the art at that moment, which was 55%. And this approach turned out to be so successful, so effective, that it was even became a part of a new family of GPT models. So OpenAI introduced their O1 model, which actually was kind of implementing this chain of thought. And I think yesterday I was given access to O3 model, so I think it's now public. It's even better a model that also relies heavily on this chain of thought idea. And so when this O1 model was introduced, it's also delivered an immediate effect in all sorts of kind of reasoning tasks like mathematics, coding, etc. So for example, for math tasks, the performance improved from 13% for previously best model GPT-4o to 83%. And for code, it was like from 11 to 89%. So there was like huge increase in performance. So interestingly, there was no increase in performance for writing or editing text. And that's because, this model were not actually struggling with this before. So this was performance kind of focused on these reasoning skills of the large language models. So there are some other approaches that also work really well, and one of them is what's called few-shot learning, is when you just provide model with a couple of examples. So this was introduced in the paper called Language Models Are Few-Shot Learners, and then also kind of tested a couple of settings. So the normal setting is just zero-shot learning, when you just say, translate English to French, and then you just provide a task. You can also make it one-shot learning when you also provide a single example. And finally, you can make it few-shot learning when you provide a couple of examples. So what researchers have found is that the performance significantly improved just with providing one example. So from something below 10% to 46% or so for one example, and it continued to improve with more examples, but not so dramatically. They also discovered in this paper that this was true only for large models, and for smaller models you still can get some improvements in performance, but not as dramatic, and for like really small models you don't see much of improvement. So this effect seems to be reserved for really large models. And so in the tasks that they were given, they also see some kind of quite remarkable results. So one task that they were given was called like cycle letters in a word. So the idea is just you shift all letters in the word to one position, and then you also put the last word to the first position. And just basic models like GPT-3, they were really struggling with this task. They were able to solve only like 3% of cases. But it was enough to provide just one example of how to do this, to performance to jump to 21 and 7%. And with a couple of examples, it can be almost 40%. So again, you can see tenfold increase in performance just by changing a bit your prompt. So there are some techniques with prompt engineering when you can drastically improve the results of your model. Finally, there are some other strategies that can be useful. For example, we discussed that the model has this tendency kind of to please you, and they always try to come up with an answer, even they don't really know the answer. So to mitigate this, you can just directly ask model not to invent anything. You can say, you're allowed to say don't know. If you don't have any confirmation of something, just say I don't know, I don't have enough information. You also can ask it to give you direct quotes. For example, if you're analyzing a document and you're afraid that it will invent something, you can say, if you claim something, please provide a direct quote from the original document, and it will do this. And you can then, it can still kind of hallucinate. It can return you something that's wrong, but you will be always able to check this citation and to see if everything is okay. Another approach is just to run model a couple of times. So you might not get the best result from the first run, but you might run a second time and select the best of them. Or you can you ask model to refine its own answer. So you run it once and then you say please check the answer if it's really correct, and sometimes it will self-correct. Someone was asking me if it makes sense to talk nicely to the models, and I think there was like some anecdotal evidence that it's kind of good to talk nicely to models. There was a paper again that was investigating that, and they asked the same kind of question with 8 levels of politeness, and they were checking the performance on different data sets of different models. So there was 3 models and 3 data sets. So, and what they have found is that there was nothing consistent. So yes, for one of the models, given the most polite answer, the most polite request was actually the best, but sometimes it was something in the middle. So the only result that was really consistent is that if you are making requests you're really in polite way, then the performance would be the lowest. So you can see this in the last row, and it's more easy to see on this heat map when you compare different politeness level with each other, and you can see that if you compare the least polite response to everything else, it would be like worse. But other than that, there was no like strong pattern. So sometimes something in the middle is better. So Yeah, the only advice that I can say is that try not to be extremely harsh with these models, but other than that, there is not much evidence that it's useful. So there are some powerful approaches to prompt engineering, but I still think that it's not so important, and mainly because most of this was kind of already implemented natively. So in this new generation of reasoning models, that's now don't it's not only ChatGPT, but also other models also have this mode. They kind of already implement chain of thought. You don't need to use prompt for that. Also, people, developers realize that the model tend to give you answer when even they don't know the answer. They're now also like fixing this, and the models like GPT-4 do much better than GPT-3. Using like direct quotes is also not now part of many chatbots, and this best of n verification and iterative refinement often happen invisibly for you. So when you talk with ChatGPT, it's not necessarily just one run of one model. It could be that OpenAI runs a couple of models and then another model decides what's the best answer. So it also can be natively implemented. So, and there's no reason to believe that if there's something like really powerful technique regarding prompts, if it will be discovered, then there would be no reason for developers just not to implement it themselves. So I think in that sense, you shouldn't really worry about learning some like secrets of prompt engineering. But some things are still useful to know. For example, it's useful to know that it's always helpful to provide model with a couple of examples. This cannot be natively implemented because examples, it's something that only you can provide because only you know what exactly you want to do. So, but other than that, I think you shouldn't worry too much about prompt engineering. And last final advice is that you can actually use LLMs to help you to create prompts for LLMs. It's usually helping with creating like a really detailed prompts, and it helps you to think about what it might be useful to consider. Yeah, let's say I wanted to create a story about Australia, and then I need to ask for ideas. And my immediate approach might be just to say, help me to create a story about Australia, but that would be like too short, too general. And when I asked ChatGPT to help me to refine this prompt, it came up with a more sophisticated prompt that was, it was starting again with this kind of role assignment, which I'm not sure if it's useful, but, why not? It was saying that you're an expert creative writing assistant. And then it was, providing a detailed guideline. There was like 6 points to this guideline. And it doesn't mean that providing this details prompt automatically force model to follow it. Sometimes it doesn't follow instructions very well. It also doesn't mean that what this model included is equally important for me. But I think it's a good starting point. And then I can just change, okay, it's reminded me that it might be good to tell model what size I'm expecting to, so I can say, okay, actually I didn't thought about it, but maybe I need something like in 200 words, 2000 words. And I can just check if I like what is there or not. So that's all what I wanted to share with you regarding prompt engineering. I see you in next videos.